For lesson 13.2, theoretical probability of compound events, we're going to build off of what we did in 13.1 with single events, and then talk about our standards and talk about our statistics and probability standard number 8. So how do you find the probability of a compound event? So if you recall in module 12, we talked about simple versus compound events. Simple uses just a single outcome to try to figure out, like say a single coin or a cube, a dice. When we use a compound event, we're going to use two things together to try to figure that out. So here in the first explore activity, we're going to use two cubes to find the probability, and we're going to create a table to help us. Recall that a compound event consists of two or more simple events. And to find that probability, you're going to write a ratio, the number of ways the compound events can happen, to the total number of equally likely possible outcomes. So Jacob rolls two fair number cubes. Find the probability that the sum of the numbers he rolls is 8. So in step 1, we have to use this table. We're going to take two cubes and we're going to roll them. Find your sample. Each cell in the sum is the first number in that row and column. So the way this works is that we're going to take 1 plus 1 and that equals 2. We take 1 plus 2 and that equals 3. And we take 1 plus 3 and that equals 4, and so on. And we continue to do this in other examples. I take 4 plus 1 and that equals 5, 4 plus 2, that equals 6, and so forth. So since we're looking for the number 8, I've completed the table here. And if we take a look here, every time when we roll the two dice, here's the one dice, I got a 2 and I got a 6 off the other one. So I have an 8. I have an 8 from the combination of 3 and 5. I have an 8 from the combination of 4 and 4. I have an 8 from the combination of 5 and 3. And I have an 8 from the combination of 6 and 2. So I have 1, 2, 3, 4, 5 possibilities that I could get a number 8. So how many possible outcomes are there in the sample space? Well, that's going to be 6 by 6, so that's 36. Circle the outcomes of 8, which we did. How many are there? There's 5 of them. So what's the probability of rolling a sum of 8? So that's going to be 5 out of 36. And of course, if you could simplify that, you would. Another way that we can look at finding probabilities is use what we call a tree diagram. And that's exactly what the name says. So you got a big trunk, that's your first branch, so that would be right here. Then you start going off into your main trunks or your main branches as they branch off, and that would be right here. And then you get off into your smaller ones, and that one would be right here. So that's where the tree diagram name comes up. It gives you a different way to visualize your theoretical probabilities on something for those compound events. Before the compound events, we were looking at just doing two things. Now this gives us a way to look at more than two things. And here in example 1, we're actually going to look at 3. And I'm going to show you an example of how we could even take this and go and look at 4 events. So a deli prepares sandwiches with one type of bread, it's white or wheat, one type of meat, which is ham, turkey, or chicken, and one type of cheese, which is cheddar or Swiss. So each combination is equally likely, so you have no idea of what you're going to get. Find the probability of choosing a sandwich at random and getting turkey and Swiss on wheat bread. So we're going to be looking for turkey with Swiss as cheese and wheat bread. So the first thing, we only have 2 breads, so that's white or wheat. The next thing, we have meat. We could have ham on the white, we could have turkey on the white, we could have chicken on the white. And we have the same thing down here for wheat, ham, turkey, or chicken. The last thing is that the type of cheese. We could have cheddar or Swiss, which would be on the ham on the white, a cheddar or Swiss cheese on the turkey on the white, or cheddar and Swiss on the chicken on the white bread. and then it's duplicated down here in the wheat section. So the next part is, that's our tree diagram there. The next part then is find the number of possible outcomes in this sample, and they found that it's 12. Well, what they did was they counted up the total here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't worry about the names in there. You're just counting up the number of events that could happen. The last thing is that we're going to look then is we want turkey on Swiss on wheat bread. So we're going to look here at the wheat bread. We're going to look at the turkey, and we're going to look at Swiss. And in this example, we only have one opportunity that we can have all of that in 12. So our probability then is 1 out of 12 that we will get a turkey and Swiss on wheat bread. So I said a moment ago that we could even extend this out one more time. So what if we had a column called spread? And we're talking about like mustard. We're talking about some people put butter on. Some people put ketchup on. You know, or any other types of spread that you would put on any of these sandwiches. So then we would take cheddar would go to mustard, butter, and ketchup. And then we would duplicate this again. So what happens now, our probability is going to change. If I want white ham with Swiss cheese and mustard, okay, so I have to recount. Now remember, this is, I've added 3 outcomes here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm putting 3 more on each one of these because this one would be mustard, butter, and ketchup, and we do the same thing here and here and here and all the way down. So now if I take 3 times 12 to make it easy, I now have 36 possible outcomes. And if I wanted the white with ham and Swiss and mustard, I still only have 1, but I've changed my probability. So the tree diagram is pretty powerful on helping you be able to visualize and come up with your different outcomes. So down here in the year term, it says use the diagram from example 1 to find the probability. So I'm going to look at ham sandwich to sort of help you out in how you would look at this. So what I want to do is I'm going to circle ham, and I got ham because the only statement, it says ham sandwich. It doesn't say whether it's on white or wheat. So I have to assume that I'm looking at white and I'm looking at wheat, okay? But that's not where I go and I say I got 2 outcomes out of 12. It also doesn't say that whether it's cheddar or Swiss. So I have to look at both of these outcomes here and both of these outcomes here. So I have 1, 2, 3, 4. So then my chances of getting a ham sandwich are 4 out of 12 because we had 12 total outcomes there. Another way we can look at probabilities is using a list, and we have this security code example to help us understand that. So the combination for Kiam's locker is a 3-digit code that uses the numbers 1, 2, and 3. Any of these numbers may be repeated. Find the probability that Kiam's randomly assigned number is 222. Well, certainly, you know, off the top of your head, there can only be one 222. So we already know the probability, well, we believe, and if we're certain, is going to be 1 out of something. So what we need to do is we need to find out what the total is. So by setting up a list here, what you do, it says list all the codes that start with 1 and have 1 as a second digit. So that's what they did here. Then it says list all the codes that start with 1 and have 2 as a second digit. And we're trying to use up all our combinations. So here, the 1's the first digit, 1's the second digit, we got 1, 2, 3. Then we have 1's the first digit, 2's the second digit, 1, 2, 3. And then we do this again, we have 1's the first digit, 3 is the second digit, 1, 2, 3. So just in this combination right here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 probabilities there. Then we have to go ahead and we have to repeat that for the 2's and the 3's, and we do the same thing. So we look down here, they don't have all the lists for number 2. They have these lists going horizontal like this. They did the 2s, and then you have 1s, and then 1, 2, 3, 2s, 2s, 1, 2, 3, 2s, 3s, 1, 2, 3. But you still have the same outcome. You still have 1, 2, 3, 4, 5, 6, 7, 8, 9. So remember, we had 9 there, we had 9 here, we had 9 here. So our total outcomes are 27. So then the probability of getting, and if you look, we only have 1, 2, 2, 2. So the probability is getting 1 out of 27 through those. So here in the Your Turn, Martha types a 4-digit code into a keypad to unlock her car door. The code uses the numbers 1 and 0. If the digits are selected at random, what's the probability of getting a code of exactly 2 zeros? What I did was I've created the start of this. So it said a 4-digit keypad, okay? So here's the 4 positions right there, okay? And I just started putting in my numbers. So again, they're only using 0s and 1s. So the first one I put in is that this could be a combination. The next one, this could be a combination, and so forth. And if you kind of see, there's a pattern here. But I did not finish this, okay? So the next one after this then would be 1, 0, 0, 0, and you would continue on until ultimately you would end up with all 1s here. So you work on figuring this out. Then the next piece you have to figure out is say, what's the probability of getting a code with exactly 2 zeros? Okay, so if we looked from what I have already done, that's exactly 2 zeros, that's exactly 2 zeros, that's exactly 2 zeros, and then you would continue on. So at some point then you're going to come out with the probability of some number, and I'm just going to call that A, over the total. So you have to work to get the total amount. That's what we did first. And then you have to find all combinations that have exactly 2 zeros. You count them up, and then that's what would go here in the A position. The rest of this is guided practice and independent practice questions. If you have needed any help, let me know and I'll help you out. Have a good day.